This video is for the notes of Unit 2, Lesson 2. We're going to talk about inverses of functions. We're going to start this set of notes with some main ideas, some vocabulary, a bunch of words really, and then we'll jump right into what an inverse is, how to find that mathematically. So it says, when finding the inverse of functions, the biggest thing, this is like the most important part of inverses. When you find an inverse of a function, all the x and y values and coordinates are going to switch. And we're going to look at what that means in a minute, but we're going to write it here so that we can use it for reference. Okay. The next blank, it says if you're given an equation, you're going to switch the x and y letters. Okay. Now we're going to be graphing inverses. So when we graph these inverses, we're going to make sure that we solve our equation for y. That's what we were practicing with our practice lesson here on graphing equations. How do I solve for y so that I can graph the line? Now it says there's a special notation for inverse functions. It says normally we have a function that's f of x. Now an inverse function is written this way. F, there's a little exponent of -1. Oops, I wrote that wrong. Exponent of -1 to the x. That what you say there is f inverse of x. Right? We're going to be using that notation, or you're going to be seeing it, and you should recognize that that means the inverse of a function. Now, if we switch the x and y coordinates, it says, what's the implication of switching the x and y coordinates? Well, remember, the x's is what we call the domain. The y is what we call the range of a function. So if I switch the x's and y's to get the inverse, that means that I also switch the domain and the range. And again, we're going to talk about that a little bit later today. Now finally, inverses are mirror images of each other. So when you find an inverse, they are going to reflect over the line y equals x. We're going to look at that in just a minute here in example 1. So let's try a couple. It says we're going to graph the line 2/3 x minus 2 on this grid. Then we're going to label it. So let's start there. To graph this line, you need to know that the y-intercept is at -2, and the slope is 2/3. So we're going to go up 2, right 3. Now when we graph these, I want you to graph them as carefully as possible. Plot as many points as you can and connect them with a nice straight line. That is your equation, f of x, right? It says to label that. That's where we're starting. Now, it says what we're going to do is we are going to take this equation and switch the letters x and y. So what I mean by that is instead of y right here, you're going to write x equals 2/3 y minus 2. You take those letters and just flip-flop their position. That's the equation of the inverse, but we can't graph it until it says y equals. So we're going to solve for y by adding 2 to both sides. We'll get x plus 2 equals 2/3 y. Now the next thing I would do is get rid of this fraction. I'm going to start by multiplying both sides by 3. Multiply everything by 3 so that that denominator goes away. Well, 3 times x is 3x. 2 times 3 is 6. And that equals 2y right now. The last step is I have to divide everything by 2. So I'll get 3x over 2 plus 3 equals y. Now that equation right there, that is the inverse function, f inverse of x. So we're going to graph that on our grid, and we're going to see what we notice here. The y-intercept's at 3, and the slope this time is the fraction 3/2. So you're going to go up 3, right 2. And again, you're going to go in both directions here so that you can graph the line as carefully as possible. That line I just graphed, we're going to label as f inverse of x. Now you should notice that those graphs look kind of symmetric. We're going to graph the line y equals x. And y equals x, I'm going to graph it here. That is the line that goes right through, so the line y equals x here goes through the origin, and you should notice that that has a slope. It goes through the origin with a slope of 1, right? Y equals x has a slope of 1 in front of the x here. So that's that dotted pink line. And you should notice that your two graphs, f and f inverse, reflect over that line. Let's look at another example. Number 2, same kind of thing. We're going to graph negative 3/5 x minus 6. You doing okay, Maddie? All right, so to start here, we have to notice that our y-intercept is at negative 6. So that's our b. We plot a point. And then our slope is negative 3 over 5. So you're going to go down 3 and right 5. Remember, our slope is always down or up or down and then to the right. Now, keep plotting your points here till you run out of room. You can connect those. Oops, it's not super straight, but it's good enough. And we'll say that that line is called g of x. They want us to label it again. That's where we started. Now we're going to find its inverse. So just like the last problem, remember g of x is the same thing as y equals. So I'm going to switch the letters x and y. So to start here, I'm going to write x equals, instead of y equals, negative 3/5 y minus 6. You just flip-flop the letters. That's all we started with right here. Now what we need to do is we need to get y by itself. So we're going to start by adding 6 to both sides. We'll get x plus 6 equals negative 3 over 5y. All right, now we're going to do the same thing we did in the last problem. We need to clear the fraction. And to do that, I'm going to start by multiplying by everything by the denominator. That makes the 5 in the right go away. And on the left-hand side, we now have 5x plus 30 equals negative 3y. Now to get y by itself, you're going to divide everything by negative 3. And what you get when you're done here is y equals, this fraction stays the same, negative 5 over 3x. Now 30 divided by negative 3 is negative 10. That is the equation of the inverse, and we can write that either as y equals or g inverse of x equals. So let's graph it. Our y-intercept here is at negative 10, and our slope is negative 5 over 3. Now I don't really have room to go down to the right and to the right here, so I'm going to go up 5, left 3. I'm going to work backwards this time. So up 5, left 3. So this line, when I connect it, looks like this. That is g inverse of x. Now it says to finish here, you need to graph the line y equals x. Remember, y equals x starts at the origin, and it has a slope of 1. So it is this line right here that just goes from corner to corner. And you should be able to see that those two lines, g and g inverse, reflect over the pink line, y equals x. All right, now we're just going to practice a couple more times with finding the equations of inverses here. Okay, one more, or a couple more here, I'm sorry, A, B, and C, and then we will move on to some stuff with composition. So when we find the inverse, remember this f of x is the same thing, I don't want to write that there. F of x is the same thing as y. So you really just have y equals negative 2x plus 3. To find the inverse, biggest thing, so, interchange x and y. That means flip this. X equals negative 2y plus 3. All we have to do is solve for y, and then we'll be finished. So I start by subtracting 3 from both sides. When I do that, I get x minus 3 equals negative 2y. Now, to get this y by itself, I divide every term by negative 2. Right, so I have x over negative 2. That can stay the same. A negative fraction, negative over a negative here, turns into a positive 3 over 2. And that equals y. That is the inverse. You can leave your answer just like that. Part B, again, this g of x is the same thing as y equals. I need to find the inverse. So I'm going to start by switching these two letters. X equals negative 1/5 y minus 1. All right, so I'm going to get y by itself by starting to add 1 to both sides. You get x plus 1 equals negative 1/5 y. Now, just like we did in the first couple problems, when I have a fraction, we need to clear the denominator, which means we multiply every single term by that denominator of 5. The 5s are going to cancel, and you have 5x plus 5 equals negative 1y. Now, we're almost done, but we have to get y by itself, which means I have to divide everything now by negative 1. When I divide by negative 1, I get y equals 5 divided by negative 1 is negative 5x, and same here, negative 5. So that is the whole equation. That is what the inverse function equals. All right, last one, h of x. Again, that's the same as y equals. To find the inverse, you switch x and y to start. So x equals 7y plus 18 over 2. Now with this one, I need to clear the denominator. So I need to multiply both sides by 2. 2 times x gives me 2x equals 7y plus 18. To get y by itself, the next thing I would do is subtract 18 from both sides. So I have 2x minus 18 equals 7y. And I have to divide every term by 7. Well, I'm going to have some goofy looking fractions, but that's okay. I have 2 over 7x minus 18 over 7. You can just leave it as a fraction. No need to take out your calculator to make it a decimal. Equals y. And that is the equation of the inverse. So hopefully you're feeling pretty confident with finding the equation of inverses right now. Next, we need to explore a little bit more about the relationship between a function and its inverse. We're going to use composition. This is taking us back to Unit 1. So we're going to do 2 compositions for each problem. So we're going to be given a function f of x and a function g of x. The first composition we're going to do is to find f of g of x. It's what we were doing in lesson 1 of this unit. Remember, to find a composition, you take the letter on the right, that function, and you put it into the letter on the left. So this function of g is going into the function of f for x. So instead of x in the function of f, I am going to put x minus 5. Now all I have to do is simplify this. And you should be able to notice, well, negative 5 plus 5 cancels off. That gives me an answer of x. That's the final answer. When I look at b here, I'm going to do a similar composition, but I'm going to take the function of f and put it into g. So here, I'm going to take x plus 5 and put it in to g here. So remember, we write our x. We finish the function of g, and I'm going to put the function of f into that parentheses. Now notice, positive 5 minus 5 cancels to 0, so again, this composition equals x. You should notice that the result of both compositions here was x. That means something. We're going to look at that in just a second. Let's look at number 2. 2 is going to give us a similar answer, and we'll be able to see a pattern. So it says, given f of x is 1/2 x plus 3 and g of x is 2x minus 6. We're going to find both compositions. Now here's that goofy looking composition notation, f of g of x. Same thing, I start on the right. G goes into f. So g here is going to go into f for the value of x. So I start by writing f. I put parentheses where the x goes. And then in that parentheses, I'm going to put my function of g. Now what I have to do is I'm going to simplify this. I want to get it as simplified as possible. So I'm going to distribute 1/2. 1/2 times 2 is 1, so it's just x. 1/2 times 6 is -3. And then I have plus 3. Well, -3 plus 3 add to 0, so the answer here is x. All right, let's see what happens in B. This time I'm taking f and putting it into g. So you're going to take this function of f right here and put it in to g for x. So remember, we start by writing the function of g. You put parentheses where the x is. And inside those parentheses, you fill your function of f. Same as the last problem, I'm going to start by distributing. We distribute the 2 to both problems. 2 times 1/2 is 1, so it's 1x. 2 times 3 is 6, and then I have my minus 6. Well, 6 minus 6 cancel off to 0. I'm left with x again. So it seems like this time both compositions also gave me the answer of x. This is the big thing here. It looks like these two functions were inverses if and only if both compositions equaled x. That means f of g of x gave me an answer of x, and g of f of x also gave me an answer of x. When you compose two functions, if both compositions, both ways, give you an answer of x, then those two functions are inverses. So let's try this one more time with a little bit more complicated looking problem. We're going to prove or show that these two functions are inverses. To do this, we're going to first find f of g of x, and then we're going to do g of f of x. So in order to show two functions are inverses, again, you need to do two compositions. So to start here, I'm going to do the left one, f of g. G is going to go into f. So we're going to take this whole fraction and put it in for x in f. So what you have here, remember we start with f. So I'm going to start with this -4, put my parentheses, plus 1. Now inside the parentheses, you're going to put your function of g, -x plus 1 over 4. Well, what we're going to do is remember that this -4 is like a fraction. It's -4 over 1. And we're multiplying a fraction here. So we're going to distribute the -4 to the numerator so I can multiply the numerators together. And then I'm going to multiply the denominators 1 times 4. -4 times -x gives me a positive 4x. And -4 times 1 gives me -4. The denominator, I multiply the 1 times the 4 here, which is the denominator of 4. And then I'm going to tack my plus 1 on the end. Well, let's simplify. 4x over 4, that's just 1x, minus, because there's a minus in the middle, 4 over 4 equals 1, plus 1. Well, just like we've seen, the 1's cancel, and this composition gives you a value of x. So far so good. I have the x that I want. But I have to make sure that the other composition also gives me a value of x. So this time I'm going to put f into the function of g. So I start with my function of g. I put parentheses where the x would go. And I'm going to fill in the value of x, negative 4x plus 1. To simplify this, I'm going to start by distributing the negative here in front. Negative 1 times negative 4 is positive 4x. Negative times a positive is negative 1. I got a plus 1 on the end, all over 4. Now the next thing I have to do is simplify these 1's up here. Negative 1 plus 1 go away. That leaves you with 4x over 4, which allows you to cancel the 4's off and give you a value of x. So since I have x for its both compositions, that tells me that those two functions are inverses. That's exactly what we wanted. All right, there's going to be some practice that you need to do. This is a little bit more challenging, so let's make sure we do the practice. Keys are going to be on Canvas, and the video for practice as well will also be on Canvas.